Hello and welcome to the channel Science Match Engineering. Today we are going to solve the Assam Public Service Commission, that is APSC's Assam Electricity Grid Corporation Limited, that is Aegcl 2023 Mechanical Engineering paper for Assistant Engineer Part 3. So let's get started. Question 51. The process in which work is provided with the cutting motion whereas feed is given to the tool is known as, so it is known as planing. So it is achieved by a hand planer or a power planer. Okay, and the power planer is also simply known as planer. Okay, so we'll go to the next question. The face of the tool in contact with the chip is called, so it is called rake face. Okay, so next question. Taylor's tool life equation is, so it is given by p to the power n, t to the power n equal to constant, where p is the cutting speed in meter per minute and t is the tool life in minute and n and c are constants. So we'll go to the next question. The operation of cutting internal thread of small diameter is called, so it is called tapping. So in this case, a tap is of suitable size is used and it is used to cut the internal threads in the workpiece. And if for these small diameters, if we need to cut the external thread, then we use a die and the process is called dyeing operation. So go to the next question. ABC inventory control focuses on those. So ABC inventory focuses on items which consume more money or which are expensive. Now there are items in any institution where the top 10 items consume around 70% of the expenditure, so these are classified as A. Then 20% of the items consume 20% of the expenditure, this is classified as B, and that 70% of the items consume 10% of the expenditure, and these are classified as C. So it is always it is focused that the A inventory is kept in such a way that we have the least wastage, but we can maintain our work as per schedule. Okay, so we'll go to the next question. Which of the following is not an input in the material requirement planning process, that is the MRP process? So the answer is the material requirement planning process uses the master file, the product structure file and the master production schedule as inputs, whereas it gives the planned order report as output. So the planned order report is not an input to the material requirement planning process. Okay, we'll go to the next question. Two unequal forces acting at a point at an angle of 150 degree have a resultant which is perpendicular to the smaller force. The larger force is 24 Newton. So we need to find the smaller force. So the answer is, say this, let this be P and Q and they have an angle between them is alpha which is equal to 150 degree. Now let Q be the larger force. So R and P have an angle theta and this theta is 90 degree in our case. Okay. Now from mechanics we know that tan theta is equal to Q sin alpha by P plus Q cos alpha. So from here we know P plus Q cos alpha is equal to Q sin alpha by tan theta. Now tan of 90 degree is infinite, so 1 by tan theta would be 0. So we have P plus Q cos alpha equal to 0. So P is equal to minus Q cos alpha, so which is equal to minus 24 into cos of 150 degree is minus root 3 by 2. So we get 12 root 3 or 21 Newton. So answer is 21 Newton. So go to the next question. A column of length L has one end fixed and the other end pin jointed. The equivalent length of the column will be, so if we have both ends hinged, then the equivalent length is L. If we have one end fixed and the other free, then the equivalent length is twice L. If both ends are fixed, then the equivalent length is L by 2. Whereas if one end is fixed and the other is hinged, then our equivalent length is L by root 2. So in our case, it is one end fixed and one end pin jointed, so it will be L by root 2. So go to the next question. At the point of impeding motion, A, the body is on the verge of moving. B, the frictional force reaches the maximum value. C, the frictional force is equal to the tangential applied force. And D, all of the above. So the answer is, it is all of the above, because impeding means it is just going to start. So at the point of impeding motion, that means the body is already in the verge of moving. So as it is on the verge of moving, so the frictional force has reached its maximum value and this is known as the limiting force of friction. And now till now it has not moved. This force is equal to the tangential applied force then, because then only they are in equilibrium. Once this starts moving, then we will have this frictional force plus the acceleration at which the body is moving plus the force produced from the acceleration. Okay, so go to the next question. In fact, the force required for the acceleration. So next question. The rectilinear motion of a particle is governed by A is equal to minus 16 by x cube, where A is in meter per second square and x is in meter. Given that at time t is equal to 1 second, x equal to 2 meter and v is equal to 2 meter per second, the position at t is equal to 4 second is, so the answer is, see, A we know is dv by dt, so it is equal to dv by dx into dx by dt. So from here we get dx by dt is v, so it is v dv by dx. Now A already we know it is minus 16 by x cube. So what we get, v dv is equal to minus 16 by x cube into dx. So from here we get v square by 2 from integrating is equal to minus 16 by minus 2x square plus c1, or v square by 2 is equal to 8 by x square plus c1. Now at t is equal to 1 second, x equal to 2 and v is equal to 2. So you get 2 is equal to 2 plus c1. So c1 would be 0. So v square by 2 is equal to 8 by x square plus 0. So we get v square equal to 16 by x square, or v is equal to 4 by x. Now dx by dt, v is dx by dt. So dx by dt would be equal to 4 by x. So from here we get x dx is equal to 4 dt. So we get x square by 2 is equal to 4t plus c2. Now again from the same condition we get that x is 2 and t is 1. So we get that c2 would be equal to minus 2 then. So we have x square equal to 8t minus 4. So once we shift this 2 here, so we get x square equal to 8t minus 4. So from here, once we put t is equal to 4, what we get is that x is equal to root over 28, which is equal to 5.29 meter. Okay, so go to the next question. A block of 150 Newton weight is resting on a rough horizontal table. The coefficient of kinetic friction between the contact surface is 0.2. The horizontal force required to move the block with acceleration of 1.5 meter per second is determined to be, so the answer is, say, normal force R is equal to W. Now limiting force of friction F is equal to mu R. So we get F is equal to 0.2 into 150, that is 30 Newton. Okay. Now this P, apart from this, it is already exceeding the limiting force of friction and then accelerating at a force of 1.5 meter per second square. So P would be equal to this frictional force plus M into A. Now what is M? Mass of the body would be equal to 150 Newton divided by 9.81. Acceleration due to gravity is 9.81. So 150 by 9.81. So P would be equal to F plus MA, which is equal to 30 plus 150 by 9.81 into 1.5. So we get P is approximately equal to 52.94 Newton. Okay, so we'll go to the next question. For an overdamped system, the value of damping ratio is, so it is greater than 1. So if it is 0, we have no damping. If it is 1, we have critically damped system. If it is less than 1, it is underdamped system. And if it is greater than 1, then it is an overdamped system. So we'll go to the next question. A vibrating system have a mass 2 kg is suspended by a spring of stiffness 800 Newton per meter and it is put to harmonic excitation of 10 Newton. If the damping is viscous, then the resonant frequency of the system will be, so the answer is, we need omega n, so resonant frequency would be equal to root over k by m. Now k is given 800, m is 2, so we get omega n is equal to 20 radian per second. So we'll go to the next question. A varying force F is equal to t square I plus 2tj is applied on a particle from time 0 t equal to 0 to 3 seconds. The impulse of the force in 3 seconds is, now impulse is given as integration of f into dt. So impulse I would be equal to integration 0 to 3 f dt. So it is comes as 9I plus 9j. So I would be what equal to, I is the magnitude, so it would be equal to then root over 9 square plus 9 square, which is equal to 9 root 2 or 12.73 Newton meter. Okay, so go to the next question. A train of 400 tons mass is pulled by a locomotive of 20 tons along level rails at a constant speed of 80 km per hour. If the force of friction is 100 Newton per ton, the driving force of the locomotive is, Now see, total mass would be equal to 400 plus 20 ton. So our mass of the whole locomotive, including train and the locomotive, would be then 420 ton. Now frictional force is how much? 100 Newton per ton. So it will be 100 into 420 Newton. So it is 42 kilonewton. Now the locomotive is moving at a constant velocity. So acceleration A is 0. So force required to pull the locomotive would be just this 42 ton, that is to overcome the frictional force, and no extra acceleration is there. So it is 42 kilonewton. Now again, speed of the locomotive would be 80 kilometer per hour. So we need to convert it into meter per second. So we just multiply it by 5 by 18. Why 5 by 18? Because kilometer is 1000 meter, hour is 3600 seconds. So 1000 by 3600, that is 5 by 18. Okay. So we multiply directly by 5 by 18. So it is 200 by 9. So driving power of the locomotive would be P is equal to F into V, which is equal to 42 into 200 by 9, that is equal to 933.34 kilowatt, or approximately equal to 934 kilowatt. So go to the next question. The maximum mechanical advantage of a lifting machine is, so it is 1 by M. Okay. So go to the next question. Polar modulus of the section of a shaft is a measure of, so it is a measure of its strength in torsion. Okay. So next question. A simply supported beam has distributed load of linearly varying intensity with 0 at one end and W per unit per run at the other. The maximum bending moment is, so the answer is, see, this is the figure. So it is W here and 0 here. So at the distance x, it would be W into x by L, right? And this, they are separated at the distance L. Okay. And since it is simply supported, so we have two reactions, RA and RB at the two ends. Okay. Now, if we try to find the moment at point B, what we have, this force will be acting at a point 2 by 3L from B. So 2 by 3L. Okay, that is the distance. And what is the weight? Weight will be half into W into L. So WL by 2 into 2L by 3. It is the moment of this uniformly varying load, and this moment would be equal to RA into L. Okay, and this is anti-clockwise, and RA into L is clockwise. Okay, so they cancel each other. Okay, so from here, that is, that body is in equilibrium. So RA is equal to WL by 3. Now RA plus RB is equal to WL by 2, right? The total weight. So RB would be equal to WL by 6. Now if we take this cross section at C and a distance x from B, what we get is that we have minus RB here, and what is this weight? This is half into Wx by L into x. So Fx would be equal to this value, minus WL by 6 plus Wx square by 2L. So for Fx equal to 0, we have Lx is equal to L by root 3. Now if the shear force is 0, then the bending moment is maximum. So if we take this small portion, right, from B to C, this portion, then if we see here, that weight would be how much? W is equal to half into Wx by L is the, till here it is varying till Wx by L, and the length is L. So this is the area of the triangle. So it is W is equal to half into Wx by L into x, that is the weight. Okay. Now at this point C, if we try to find the moment, so this W into, what is the distance it will be? From here it is 2x by 3, so this will be x by 3. So this part into x by 3, that is clockwise, the negative, and RB into x, and RB is how much? WL by 6 into x, so anti-clockwise. So this 2 becomes this one, WL by 6 into x minus this is the total moment. Okay, so from here, when we calculate, we get that moment is WL square by the moment we are finding here now. But when we put x equal to L by root 3, then we get here, till here it was x, and then when we put x equal to L by root 3, where shear force is 0, then we get the moment as WL square by 9 root 3. Okay, so go to the next question. The cross-sectional area of a solid shaft of 160 millimeter diameter is the same as of a hollow shaft of the same material, and 120 millimeter inside diameter. The angle ratio of angles of twist for the equal lengths when stressed to the same intensity is, so the answer is, and none of the options is the correct option. See, let us explore. Now, this hollow shaft pipe diameter would be what? Outer diameter minus outer area minus inner area. So pi by 4 into d square minus 120 square is would be equal to the area of the solid shaft, that is pi by 4 into 160 square. So from here we get the outer diameter is 200 millimeter. Now we see we have stress is same, length is same, and g is same as it is of the same material. So we have tau by r is equal to z theta by l. From here we get r theta is equal to constant. So r of solid into theta of solid is equal to r of hollow into theta of hollow. So theta of solid by theta of hollow is equal to r of hollow by r of solid. So r of hollow is what? 200 by 2 and r of solid is 160 by 2. From here we get it is 100 by 80 or 1.25. Okay. So this is clearly mentioned in the strength of materials book by Associator. So in case we have any more queries, since this is, I am giving this because since none of the options were correct, so we can, if you want to follow, you can follow it from there. Okay. So go to the next question. A 10-meter long simply supported beam carries 2 point loads of 10 kilonewton and 6 kilonewton at 2 meter and 9 meter respectively from the left hand. It also has a uniformly distributed load of 4 kilonewton per meter run from the for the length between 4 meter and 7 meter from the left hand. The maximum shear force is determined to be, so the answer is, see, our forces are 10 kilonewton here, 6 kilonewton here, and this 4 kilonewton per meter for a 3 meter length. So we have total of 10 plus 4 into 3 plus 6, that is 28 kilonewton, and this is supported by RA and RB. So RA plus RB would be equal to 28. Now if we take the moment at A, what we get is a 10 into 2 plus this 12, 4 into 3 is 12 into 4 plus 1.5, 4 into 3 into 4 plus 1.5, and then 6 into 9. So this moment would be equal to RB into 10. So from here we get RB is 14 kilonewton. So RA would be also 14 kilonewton. Okay. So if we draw the shear force diagram, what we see is that at A we have 14 kilonewton. Till C it is 14 kilonewton. At C it drops to 4 kilonewton and then it carries till 4 kilonewton till this point where the uniformly distributed load starts. From here it decreases to minus 8 kilonewton and then remains minus 8 kilonewton till D, and from D it goes to minus 14 kilonewton till from D to C, D to B it is minus 14 kilonewton, and at B it again goes to 0. So if we see the maximum shear force at this both ends is 14 kilonewton. So this is the maximum shear force. Okay, so option B is the correct answer. So we'll go to the next question. In a kinematic chain, a quaternary joint is equivalent to, so it is equivalent to 3 binary joints. So next question. The number of instantaneous centers for a mechanism of n links is, so it is n into n minus 1 by 2. So next question. When a point at the end of a link moves with constant angular velocity, its acceleration will have, so angular velocity omega is constant. So angular acceleration is alpha is what? d omega by dt, it is then 0. Then tangential acceleration alpha t is equal to r alpha, which is equal to 0 then. So radial or centripetal acceleration AR is will be equal to omega square r. Then as there is no Coriolis acceleration because there is no relative moving is there. Okay, so the link is not moving, so related to the body, so Coriolis acceleration is 0. So what we have is that we only have this radial acceleration. Okay, so next question. The gear by which two non-intersecting and non-parallel shafts can be connected is, so it is a spiral gear. Okay, next question. A gear with 60 teeth has pitch circle diameter of 720 centimeter. The module of the teeth is, so module is given by pitch circle diameter by number of teeth. So it is 720 by 60, that is 12 centimeter. Okay, so with this we have come to the end of the Apsc Aegcl 2023 mechanical engineering paper part 3. This is for assistant engineer. So hope you like it. We'll soon come with the last part. So thank you for watching. See you in the next one.